Welcome. Today is October 19th, 2020, and this is QM222, Quantitative Methods. And Adam and Zachary, you're pretty close to me. Can you hear and see me?
Yep.
Okay, great. By the way, that was the second time I asked, and so it was clear from the first time you were not able to hear or see me. What we're going to do today is we're going to go and finish up the midterm review. So last time we stopped at slide 19. So let me jump ahead to slide, we'll go back to like slide 18 or so, just so we have a slight overlap. Maybe we'll do slide 16 and 15. So we were talking about hypothesis testing when we ended. And the idea of hypothesis testing is that you're basically making a guess and you can be proven right or wrong. The null hypothesis, there's no difference between the sample group you're looking at and the overall population. And the alternative is that there is. And then there were a couple of steps for doing hypothesis testing. And we ended with this particular problem that managers overall across the entire country earn about $120,000 a year. You do a sample of 16 people in your company, and you find out that the average is paid $115,000 a year. And then the question is $115,000 different than $120,000? And only in quantitative methods, only in statistics, would you actually ask this kind of question. If you ask anybody randomly in Kenmore Square or any place else, you say, is there a difference between 120 and 115,000? They'd all look at you and go, what are you, an idiot? Of course there's a difference, right? One's $5,000 lower. But the key point about quantitative methods is when you're taking a survey, you're doing a sample, there's uncertainty associated with a number like $115,000. And because there's uncertainty, $115,000 could actually be the same as $120,000 if we actually gathered more information. And why don't we gather more information? Because gathering more information is costly. It takes time and takes money and takes effort. And sometimes we only have enough time, money, or effort to gather a small amount of information. And the answer was, when we ended last time on Friday, that $115,000 in this particular case was the same as $120,000. So let's do another question. Average US male is about 5'9", 5 feet tall, 9 inches. And we sample 100 men in QM222. We find the average male is 5'11". And we also find a standard deviation of 2.5 inches. So the question is, are QM222 men taller than average? And once again, if we go to Kenmore Square and ask a random passerby this question, they'd look at us like we had two heads, because yes, 5'11" is much bigger than 5'9". But once again, we're only taking a sample of QM222 men. We're only taking a sample of 100 people, so there might be actually a difference. So what we're going to do, there's a couple of different ways of doing it. Some of you have learned the t-test method, that works. Some of you have learned the confidence interval method, that works too. Both will be accepted on the midterm exam. I don't care which one you use, but let's use the confidence interval method. What we'd like to do is first figure out the standard error. What's the standard error? The standard error is the standard deviation divided by the square root of the sample size. So the standard deviation here is 2.5 inches. The sample size is the square root of 100 because there's 100 people. So it's 2.5 inches divided by 100 square root, which is 10, which is 1/4 of an inch. So what we'd like to do is we'd like to add and subtract twice. Why twice? Because we're trying to come up with a 95% confidence interval. Twice 1/4 of an inch. So twice 1/4 of an inch is 1/2 inch. So we subtract 1/2 inch from 5'11", and we add 1/2 inch to 5'11", and what do we get? 5'10.5" to 5'11.5". Since the average male is 5'9", this confidence interval is outside 5'9", and what do we say? We say, no, the two are definitely different. Okay, we can reject the null hypothesis that QM222 men are the same height as the average population. Casey, somebody else has a question. So Chris, sorry about that, Chris. I'm just blabbing on.
It's okay, Professor. I was just wondering really quick. I know that 2 comes from like that like 0.05 alpha. I was just wondering why it's like 2 and what the other numbers might be.
So in this class, so in other classes, there might be plenty of numbers, but in this class, there's only 3 numbers. There's 1, which covers 68% of the normal distribution. There's 2, which covers 95%, and 3, which covers 99.7% of the normal distribution. So we use in this class either the 68%, the 95%, or the 99.7%, but other classes, for example, might use the 90th percentile. All right, so you're right 90 out of 100 times, you're wrong 10 out of 100 times. And I think off the top of my head, that's like 1.86, but you know, I'd have to double check that. I don't know if that's answering your question. No, it's not.
I was just wondering where the 2 came from and why that from 0.05 to 2, how that kind of happens.
Because when we have this bell-shaped curve, when we take the mean, which is the peak of the bell-shaped curve, and we add and subtract 2 standard deviations, we're covering 95% of the area. And we're not covering 5%. And that's where the 2 comes from. Because adding and subtracting 2 standard deviations covers most of that bell-shaped curve. I think that was a thumbs up. It's a little hard to tell. Okay. Any other questions? So let's do a little bit of graphing. So why do we do graphing? First, one of the key points of graphing to see is there's symmetry. Is the left side and the right side the same? Or is the left side longer, or is the right side longer? So when we look and see if there's symmetry, then we know the mean and the median are both the same when the 2 sides match. Sometimes, however, we get a skewed distribution. Skewed distribution means that left-hand tail is longer or the right-hand tail is longer. Okay? And when we have a skewed distribution, the means and the medians tend not to be the same. They tend to be very different. We can also check if we have a uniform distribution. Uniform distribution means it's flat, going all the way across. And what would a uniform distribution be? So everybody has the same chance of getting something as everybody else. Quick example, at the very beginning of the semester, before people decided not to come to class, all those who were here in Boston had a uniform distribution of being randomly selected to come to class, right, and get an in-person ticket. Right? It was I'm looking at Jared right now, and I'm looking at Anya. Both of them had roughly a 45% chance the first few weeks to get an in-person ticket to class. And now, because there's only 4 people who've actually shown up today for in-person, there's still plenty of seats, your chance of getting an in-person ticket is 100%. Okay, so everybody who wants to come is invited. Uniform distribution, same probability. There's a whole bunch of different graphs. So pie charts are commonly used to display proportions, so what percentage. The problem with pie charts is they're very hard to remember the percentages. So lots of people can look at pie charts and say, that percentage is bigger than that percentage. But if you ask them a few weeks, days, hours later, they can't tell you the actual percentage itself. If you're trying to show data over time, trying to use time series data, in general, use either a line chart or a bar chart or a scatter plot. Those are the 3 big ones. So for example, if we're looking at the percentage of teenagers who smoked from 2000 to 2020, then we'd like to use either a line graph or a bar chart. Typically is the way to show trends over time. If you're trying to show how proportions change over time, proportions are percentages. How the percentages change over time. And there's more than one thing, so there's 2 or 3, then stacked bar charts are very useful. So if we're looking at the percentage of teenagers who smoke, percentage of teenagers who drink, percentage of teenagers who do both, then what we'd have is we'd have stacked bar charts where we'd have columns of different colors or different shades going over time from 2000 to 2020. One of the questions that I often get is, how do you know when to use a histogram and how do you know when to use a bar chart? And in general, the answer is very simple. Histograms are for continuous variables and bar charts are for discrete variables. And the key point is down the very bottom of the slide, or maybe it's on the next one. Oh, there it is. You can reorder a bar chart's categories. You cannot reorder a histogram. So histograms are continuous data, and you can't reorder them. Quick examples of histogram would be income. So if I'm looking at a whole bunch of different people's income, then that is a continuous variable. Why is it continuous? Because everybody has just slightly different income, even if we're all in the same category. So I believe there's 9 teaching assistants in this class. I think there's 9 sections. Yeah, there's 9 of 9. And my guess is all of them get slightly different paychecks each 2 weeks, every 2 weeks, one every week. My guess is they're all slightly different paychecks for a variety of reasons. You know, some have slightly more deductions, some have less. Some are TAing and acting as resident assistants and acting as TAing in 2 classes. Some are only TAing 1 class and not having just slight differences. And my guess is if I looked at all the paychecks, even though they're all think they're being paid the same, the actual outcome, their actual income is very different. That's my best guess. Same thing for professors. You know, professors who've been here the same amount of time, have the same faculty rank, our paychecks are all just slightly different for a variety of factors. All right, so that's continuous data. You know, there's no real gaps in it. Discrete data are gaps. So for example, if we're trying to come up with a number of people, all right, we can't have half a person. We can't have 3/4 of a person. So if we're looking at number of people, that would be discrete, not histogram data. And the key idea is that you can reorder bar charts, but you cannot reorder histograms. It doesn't make any sense. All right. So let's jump for another one down. So what would be an example of a histogram, of a bar chart? Data on the number of students in each college at Boston University. So College of Liberal Arts, College of Communications, Questrom, College of Fine Arts, CFA, the Theology School, right? Which would you use, histogram or a bar graph? Anybody out there in Zoom land?
A bar graph.
Great, thank you very much, whoever said that. Who was it?
Harrison.
Thanks, Harrison. Please give Harrison class contribution for today. So why is it bar graph? Because it doesn't matter who's first. The Questrom could be first, CFA could be first, College of Communications could be first. Now, we do know which should be first, Questrom, because Questrom's #1 of all the BU colleges, but that doesn't necessarily mean it will be first. That's a joke. It's very hard to see me smiling wearing a mask, okay? So, but we can reorder. We don't have to have always Questrom #1. Data on income, histogram or a bar graph. It's going to be a histogram. Why? Because we can't reorder. We can't take 90,000 and move it less than 70,000. It just doesn't really make a lot of sense. Okay. You have data on the number of years people under 25 have attended college. Histogram or bar graph? Anybody want to make a guess? Zach?
Would that be a histogram?
I would agree. I would use a histogram because if somebody has 5 years of college and somebody else has 4, we don't want to put the 4 category after the 5. It basically, I mean, it is possible to reorder them, but most of us would look at that and go, that doesn't make any sense. So we're expecting things to go 0. I've had 0 years of college, 1 year of college, 2, 3, 4, and so on. So that we have basically up to like 0 to 7 or maybe 0 to 8 years. Great job, Zach. Questions before we go on? So correlation. Hopefully it will not be a surprise that there are hypothesis tests on the exam. Hopefully it will not be a surprise that there are correlation questions on the exam. So if you're not really sure on correlation, I would pay attention for the next 4 or 5 minutes before going back to Twitter or Facebook or whatever else. Okay. So correlation basically shows how 2 variables, 2 columns of data move together. And they range from -1 to +1. Oftentimes when you're looking at exams or old exams or practice things, correlation is used the symbol R, the lowercase letter R for correlation. I have no idea why they don't use the letter C, okay? But that's historically, they've used the lowercase r for correlation. Okay. The correlation ranges from -1 to +1. +1 means perfect positive correlation. When one thing goes up, the other series goes up also. When one series goes down, the other series goes down. Conversely, a -1 means the exact opposite. So when one series goes up, the other series goes down. And 0 means no relationship at all. And the numbers can be any kind of range from -1 to +1. It doesn't have to take just those three values. It could be like a quarter, a third, a half, and so on. So here's three graphs. Does anybody want to take the far left one? The far left one. What do you think the graph is? Is it positive, negative, and 0? Roughly, what would you say the value is?
Positive?
Okay, just tell us who was that? Who just
Oh,
said
that
that?
was Jordan.
Okay, thank you, Martin. So the first one is positive, and you think, can you give us a number between 0 and +1?
Maybe like closer to 1 plus
Okay.
1.
All right, so close. You will have a 0.9 or something?
Yeah.
Okay, sounds good. How about the middle one, number B?
Negative.
Negative.
All right.
Negative.
And what would your value be?
0.65.
0.65 minus 0.65. Okay, and the last one, C, the right-hand side one. So we have a positive one, and you want to give a number? 0.3. We have a positive 0.3. So let's find out the exact answers, which are hidden in the notes section. Because to be honest, I didn't memorize them. 0.9. Nice job. Was that Harrison, the first one who did? Nice job. The middle one was negative, minus 0.8, and the far one was 0.7. So pretty good for guessing. Anybody want me to stop and go over any of these? Positive, negative, or 0. What's roughly the value for these three pictures? How about the left one? Chris, go for it.
I'd say it's pretty close to 0, maybe positive.
Maybe positive, close to 0. Adam, you want to do the middle one?
I'd say like negative, but like maybe like really close to 0.
Okay, so we have a positive close to 0, a negative close to 0. Anybody else on Zoom want to do the far right one?
I'd say it's
0.
like 0. Yeah.
All right, so the answers are hiding below in the notes section. The left one was a positive 0.3. The middle one was a negative 0.2 correlation. The right one was 0.1. So nice job, all of you. Please pat yourselves on the back. All right, if I was to mark a couple of slides with stars in the review, this would be one of my, let's go back and review this particular page. So there's lots of correlation tables, and one of the questions I got this morning was, when do you do a correlation table? When do you do the Excel function? And the answer in the real world is pretty simple. If you're just looking at 2 columns of data, then you do the Excel function correl. But if you have lots and lots of variables, where lots is somewhere greater than 4 or 5 or more, then you pretty much always want to create a correlation table because it's just faster. But if you only have 1 or 2, if you're only doing 1 or 2 correlations tables take a fair amount of time to format, bring up, do all those kind of things. So small numbers, use the equal correl function. Large numbers, where large is greater than 4 or 5, create a correlation table. Correlation tables are kind of interesting because there's a whole bunch of area that's totally missing. There's nothing in this section right here. And why isn't there anything in that section right there? Because those numbers are already shown in the table. They're missing because those numbers are already shown in the table. What do I mean by that? There's no difference between the correlation of column 1 and column 2 versus the correlation of column 2 and column 1. It doesn't matter which column is put first into the correlation function. What do I mean? So moving it around. Let's look at the second row, MPG, miles per gallon, because what we have here is we have a whole bunch of things about cars. We have price, miles per gallon, how big the trunk is, the weight, the length, all these kind of things. And if we look at miles per gallon and price, let's look at miles per gallon and length. Miles per gallon and length is missing here. But we can figure out what miles per gallon and length is because we have length and we have miles per gallon, and we can look at the miles per gallon and length column right here. And what's the value? Minus 0.796. So this value right here should be flipped on the other side of the diagonal, because it doesn't matter whether we're looking at length and miles per gallon or miles per gallon and length. Does that make sense? Along the diagonal, all the values are 1. Why? Because the relationship between being foreign car and the relationship between being a foreign car is perfect. I am a perfect match to myself. When I jump up, I jump up. Okay? When I sit down, I sit down. You know, I'm looking at Jared right here. When Jared is about to take a drink of water, when Jared takes a drink of water, he's taking a drink of water. It's a perfect match. It's not negative, it's a perfect +1 correlation. So along the correlation matrix, the diagonal is 1. Off the correlation matrix, you can always figure out what the missing values are. So there's 4 things to remember. First, 5. Correlation doesn't imply causation. Just because you see a strong relationship doesn't mean one is causing the other. There are basically 4 different cases. The first column, the X variable, causes Y. All right, so I say, I don't know, we need a good example here. I say the midterm is Tuesday night, okay? And that causes you to study. Well, it may or may not be causing you to study, okay? So X causes Y, something that I say might cause you to do something. It could be reverse causation. I would say studying and the exam, my saying, is not the opposite. I don't see any reverse causation there. It's a bad example. Let's see. All right, let's just go through the list. There's a better example on the next slide. So X could cause Y. Y could cause X, which is reverse causation. Both 1 and 2 are possible, which is known as simultaneity. They're simultaneously causing each other. And there could be a confounding factor. Let's think about a run. So if I'm running beside somebody else, okay, X could cause Y. We're running. I could be chasing them, or it could be that they're chasing me, or it could be we're both running and I'm watching them, and every time they speed up, I speed up. Every time I speed up, they speed up. Or the last is it could be a confounding factor. We both could be running because a bear is chasing us. All right? There could be something else that's going on. You ever hear that joke? Bear's chasing 2 guys in the woods, and one guy stops to tie his shoes, and the other guy goes, "What are you doing?" The guy goes, "Tying my shoes." He goes, "Why?" "It's going to make me run just a tiny bit faster." And the guy goes, "Why do you care about running a tiny bit faster?" And the guy goes, "All I have to do is run faster than you." Right? No, it's a bad joke. It's a dad joke. I'm a dad, okay? Anyways, so those are the 4 ideas here. Let's look at the next slide. So researcher finds correlation of 0.4 between personal income and number of years of college completed. Based on this finding, she can conclude, I'll be quiet for a second, A, B, C, or D. I'll let you read the 4. And then we'll take somebody online who wants to volunteer to answer what they think is best. Wow, we're up to 64 chats. Oh. That's cool. You're useful. All right, so Casey, who's gonna tell us the answer for A, B, C, or D, or E? Are you picking? Yeah, I think you are. Jada. Casey has picked Jada to answer this question.
I would say D.
So Jada says D, more years of education are associated with higher income. Jada, I give you a partial pat on the back, okay? I would say, in my mind, it's C or D. So that's why I give you only a partial pat on the back. Why is it? Rich families are able to afford places like college, able to afford things like helping people get into university. So the rich people get more education. However, more education is also associated with higher income. If you and I are almost the exact same, and I get a little bit more degrees or education, it'll probably be easier for me to find a job and probably easier for me to get a higher pay than you. So X causes Y, income causes college by like richer people get more education. It's easier for richer people to go to school. But also Y causes X. Education causes higher income. So both are working at the same time. Questions? Make sense? So here's a question from an exam a couple of years ago. I'm trying to predict the weight, which is labeled WT, of a newborn, and I'm given information about its mother and prenatal care. Prenatal care is care given while the baby is still inside the mother. MWT is the mother's weight before getting pregnant. WTGN is weight gain, how much weight the mother gained while pregnant. Smoking is how many cigarettes a day a mother smoked during pregnancy. And it is perfectly possible to have zero smoking. Perfectly possible to say, you know, I don't smoke any cigarettes. So that zero is a valid number. And PRN is how far into the pregnancy the mother was when she began receiving prenatal care, which basically is how far along before the mother visited a doctor. And we have a correlation matrix between a bunch of variables. And we have a whole bunch of numbers up there. Which variable is likely to be the best predictor of weight? So what is the best predictor of a newborn's weight? And why do we care? Because in general, the more a newborn weighs, the higher its chance of being healthy and the higher its chance of surviving into small childhood. That low weight babies, preemies in particular, tend to not have as high a success rate as full-term babies, which tend to be weighing much more. Christina, go for it.
I think it's C, smoke, because you don't look at the sign, you look at how close it is to 1 to see the strength of the relationship. And since that's 0.9, the absolute value of that is the greatest.
I would completely agree with Christina. Thank you very much. I would think that smoking is the best. And the key here is it's the absolute value of the correlation that's important, not the, you're not looking for the highest positive correlation. And the example I tend to give is whether I'm late to teaching a questrom or not is a function of traffic in Boston. When traffic in Boston is crazy, right, I tend to be late. So there's a negative correlation, but it's a very strong predictor of when I'm getting here or not. So things can be a very strong predictor, but they could have a negative relationship with the factor, with the other factor. If two variables are highly correlated, what do you know? I don't know anything. No, it's a joke. A, they always go together. B, high values of one lead to high values of the other. C, no other variables are responsible for that relationship. And D, changes in one variable are accompanied by predictable changes in the other. Anybody? Who do you think we should do? Sure. Cameron. Casey picked Cameron. Tell us what you think.
I would think that it's D.
I would agree with you. That was my answer. Nice job, Cameron.
Thank
So
you.
two variables are highly correlated. What do you know? Changes in one variable are accompanied by predictable changes in the other, but it doesn't necessarily mean that there's no other variables responsible. There is the possibility of the confounding variable. All right. B is incorrect. Why is B incorrect? Because high values of one leads to high values of the other means it's always positively correlated. B is not correct because it doesn't take into account negative correlation. And A, they always go together. Yeah, it's a okay answer, but let me tell you, we all get a little bit of training as professors in writing SAT-like questions. I don't know if you ever took like the SAT prep, and then on the SAT prep, they tell you out, there's like one or two that are always just wrong. And then there's one that's sort of okay. And then there's one that's really good. So A is sort of okay. They go together, but it's a weak answer. It's not the best answer of all of them. Does that make sense? Not make sense? It's nonsense. Biases. So choosing the right baseline is really important, and we always need to adjust so that we can make some fair comparisons. And a quick example would be you need to correct for inflation when comparing prices. I'm pretty sure I showed you the stock market over time. And I said that it looks like the stock market always goes up, but if you adjust for inflation, the stock market does not look as amazing as it did without adjusting for inflation. So part of it is when you're looking at prices over time, things always look like they're trending up. Another example of that would be people's income. If I looked at average family income in the 1950s, 60s, 70s, 80s, and 1990s and 2000s, family income in the United States looks going up steadily. But once again, we're not adjusting for inflation. So it's really important to make sure you're adjusting so you're not biased in any way, shape, or form. So here's a question. In 1980, there were 2,500 pedestrians who were struck and killed by cars. In 2018, there were about 2,700 pedestrians who were struck and killed by cars. Walking has become more dangerous, less dangerous, or more data is needed. So I would say of all the questions in this show, this is the hardest one. And I'm going to tell you the answer, and then I'm going to send you off into breakout rooms for about 3 minutes so you can discuss why you think that might be the right answer. So the right answer is B. Walking has gotten less dangerous. That is the correct answer. And I'm going to set up some breakout rooms, and I'm going to send you off to discuss why. Let me create 8 rooms. And I'll see everybody in about 3 minutes. All right, I'll give you 2 minutes too.
Professor?
This is the first time we've done this when I took the midterm
and it was on screen time last semester. And then the final, because it was we were remote, it was on it was basically like a problem set that on a question tool, but we didn't upload it ourselves. Last semester. But for core, last week for my finance and QM exam, it was an Excel sheet. So basically, and that was the first time we did it, because for last semester we didn't do that. Where basically we did the exam on Excel, like whatever. The whole, well, that's for us, our whole exam plan, so about half of yours will be on Excel, and half will be on, like the question tool, like the way to do problem sets. But I'm guessing that like for the Excel, like the way that I did for my class is that, like, you know, when you like turn in an assignment, like I just like turned in my Excel sheet.
When you upload it,
Yeah, so I guess like that would be a little bit, because I think someone like, oh, do you take screenshots and there's something else like that?
Yep.
For the Excel sheet, are they uploading it like on assignments? Or are they using?
So there's at least one question that says upload on the exam.
So it's like the problem set where you have to like do it in Excel and then just like upload the sheet.
I actually try to make the exam as close to the problem sets as possible. Not a carbon copy, so it's an exam, but
Yeah.
hopefully at the very end, whether you do well or not do well, you're like, oh, it looked like a problem set. It's the same place as the problem set. The style is the same as the problem set. There's more questions. There's 25 questions, and usually problem sets are about 12. So it's about twice as long as a problem set, and it's timed. But my whole goal is, if you're able to do problem sets, which most people seem to be able to do problem sets, or at least the problem set scores are extremely high, okay? So for whatever reason, I hope this all works out well. I will say that I am on tape right now, and I am extremely nervous about this whole learn from anywhere, test from anywhere. There's just so much that can go wrong. All right, so welcome back. And for those of you who are listening, I am very nervous. You're nervous about the midterm, and so am I. We're all losing sleep over it. I hope not, but I can tell you I'm losing sleep over it. So why do you think B? Anybody online? Chen, go for it.
So I did a small research. So I found like the population in US increased about like 100 million, like 100 millions of people during this period of time. So when you divide like this number with the corresponding population, you find that the proportion of people like who got killed by cars in 2018 actually lower than the 80s.
Please give Chen 100% class contribution, because that's really what happened. When I first started teaching here at Boston University, there was about 250 million people in the United States. And right now there's over 335 million people. All right, so as Chen said, almost 100 million extra people in this country. Basically, population has gone up by about 50%. And yes, more people are killed by cars, absolutely. But as a percentage, when you look at the number of people killed per million of people, it's gone down rather dramatically. That does not mean when this coronavirus is over, it's okay to just step into CommApp. Always look, okay? But just because there are it's safer, doesn't mean you still won't get hit. All right, you students need to look, please look. Malia, go for it.
So I'm just confused about why the answer wouldn't be C, because we did need the data. I mean, is that just like a general knowledge that the population increases?
Yeah, I would say we're assuming you have general knowledge here, and that general knowledge is pretty widespread, that there's a lot of people in the world, and there's a lot more today than there were back in 1980, which was 40 years ago.
Okay, perfect. Thank you.
Selection bias. Selection bias is when the results from a survey are wrong because an unrepresentative group was chosen. And there's 3 types of selection bias to remember: non-representative samples, survivorship, and self-selection. So let's start at the bottom of the list: self-selection. You do a survey, and the only people who respond to your survey are those people who have a special reason or a unique perspective. I don't know about you, but my cell phone and my landline, yes, I still have a landline, okay, at home. Both of them keep ringing all the time with people saying, we're doing a quick political poll, just 3 questions. Go ahead.
Christina asked if there's any questions on the exam.
Yes, there will be. Christina asked, will there be questions like the pedestrian one? Yes, there will be. So self-selection, as I was saying, lots of people call my phone and I just immediately hang up when they say political and I go click. But there are some people who really love answering political polls. They're like, I love Donald Trump or I hate Donald Trump. I really want to tell somebody that. So we get a very skewed sample. We get unrealistic and unreliable results because of self-selection. Survivorship bias. This is when we survey people multiple times. And when we survey people multiple times, not everybody answers the final surveys. So what do I mean by survivorship? Sometimes people die, but in general, survivorship bias is not because people are dying, but instead because people just drop out. So we could start with a random survey of questrom students. And then what we find is at the end of 4 years, if we survey all questrom students again, so we survey them as freshmen, we survey them as seniors, who's going to drop out over those 4 years?
The people who don't do well.
The people who don't do well are going to leave questrom. They're going to go either to another university or to another college. So what we're going to find is we're going to find survivorship bias. Those who graduate from questrom are going to be smarter than those who started questrom. They're going to be better at doing business questions. They're going to be better at things like core. Because survivorship bias, lots of people will drop out of questrom. Non-representative sample, we randomly select people, but those samples are not truly random. They don't represent everybody. So if we're trying to look at all students at BU, we probably don't want to just survey questrom students. Why? Because questrom students are better looking, more intelligent, and going to do much better in life, right? Do not post this on any website, okay? I'm going to have like College of Fine Arts students getting upset at me, all right? I'm joking, all right? Well, maybe I'm not joking, all right? I don't know. All right, so just looking at questrom students is not representative of the entire BU experience. You want to be rich, you should understand and do the same things as people who are US billionaires. This statement is wrong because it suffers from A, non-rep samples, survivorship bias, or self-selection bias. Anybody? Susie, go for it.
I said survivorship bias.
And you said it correctly. Pat yourself on the back, Susie. All right, so survivorship bias. Why? A quick story. We all use Google, right? Well, at the time Google was being invented, a few months after that, my neighbor, his backyard touches my backyard. He asked me if I wanted to join his company, and he was creating a search engine. At the time, there were hundreds of companies being created right around the same time as Google to do internet search. Who became billionaires? Sergey and Brin, who created Google. All the other hundreds of companies, my neighbor, his company went bankrupt. Just creating search engines 20 years ago didn't necessarily make you a billionaire. So right now you're looking and say, oh, to be a billionaire, you needed to get into high tech. You needed to create something like Facebook, social media, or you need to create a search engine. I would say no. Some of them got very lucky. The vast majority of people who created social media programs or created search engines went bankrupt. So survivorship bias. Regressions. We have 4 minutes left, okay? So the first is you need to identify what's the y variable and what's the x variable. And the y variable is the one that's dependent on. It's the one that x variable is completely independent. Okay, it's always on the right-hand side. The y variable is on the left-hand side of the equation. And it's sometimes a little hard. You have to sometimes read the survey, not the survey, read the exam questions to figure out which one's the y and which one's the x. But the most important part on this slide, this is the little bit I marked down, is that just because you have a regression doesn't mean you have causality. You did not prove that the x variable is causing the y variable, even though you ran a regression. All you can say is they're associated. And you can decide on the strength of that association, but you can't prove it, okay? So regression establishes the size of the relationship, but doesn't prove it. Here's an example. Let's take a dummy variable, and the dummy variable is being taught by JZ in QM222. That's a dummy variable. So there's 396 students, and 2/3 of them are not being taught by me. And on the y side, that's the x variable, being taught by JZ, 0 or 1, true or false. On the y side, we have exam score on the midterm. Now, what we're hoping is that you have a positive coefficient on having JZ, all right? That having the 1 there, that because I wrote the exam and because I'm teaching you, all right, that hopefully this translates into a better experience. And let's assume there is a positive coefficient. Let's say its positive coefficient is 3, which means having JZ boosted your exam score by an additional 3 points on average. Does that prove that JZ is a better teacher? Doesn't prove it. There's no causality there. Just because you have JZ and just because we established that JZ's students get 3 higher points doesn't mean that JZ is a better teacher in any way, shape, or form. A, we might have gotten lucky, or B, maybe I just got better students. Can't tell you. The residual. The residual is the observed value minus the predicted value or the estimated value that comes out of the regression. So if the predicted value is $10 and the actual value is 8, then the residual is -2. It is possible to have a negative residual. Let me say that again. It's possible to have a negative residual. So you run a regression which shows number of doctor visits per year as a function of times you get sick. And we have an intercept of 2. What does an intercept of 2 mean? Anybody online want to tell us what the 2 means?
That even if you don't get seriously sick, you're still going to go to the doctor twice a year.
Excellent, perfect. So maybe it's like your annual visit plus like your flu shot or something like that. So that would be the 2. And then every time you get seriously sick means you go to the doctor. Now, sometimes we get seriously sick and we don't go to the doctor. But this regression says every time you get sick, you go. So JZ, that's me. This is made up. I got sick once last year. I visited a doctor twice. What's the residual for JZ? So my predicted visits, I got sick once, so that's 1 plus 2. My predicted visits are 3, but I actually got visited twice, so it's 2 minus 3 is -1. This means the regression overestimates the number of doctor visits that I personally see or personally do. So it's exactly 110. And let me just say that I would encourage you to practice running regressions with Excel and being able to interpret the coefficients and make a prediction. And make sure they're statistically significant. How do you know if they're statistically significant? 1, first, make sure that the absolute value of the t-statistic is greater than or equal to 2. Second way, create an upper and lower bound and see if the 95% range straddles 0. If it straddles 0, it is not, N-O-T, statistically significant because it could be negative, it could be 0, it could be positive. So those are the 2 different ways to make sure they are statistically significant. Unfortunately, I'm now 30 seconds over. So let me say sorry about running a little bit late. And I wish all of you good luck either Tuesday night or Wednesday morning, depending on when you're taking the test.
Thank you, Professor.
Thank you.
Thank you, Professor.
Thank you.